Welcome back to Voyager's Window. I want to try something with you today. I want to break your brain, not permanently. Just enough that you walk away from this video seeing the night sky a little differently than before. Because we're going to talk about the size of the universe. And I mean really talk about it. Not just throw big numbers at you and call it a day. Numbers like 93 billion light years are technically accurate and completely meaningless to the human brain. We're going to actually try to feel what these scales mean. Fair warning, it doesn't get more comfortable as we go. But that's kind of the point. Let's start somewhere familiar. You are here, on Earth. Earth is about 12,700 kilometers across. The Moon sits roughly 384,000 kilometers away. About 30 Earths lined up in a row. The Sun is about 150 million kilometers from where you're standing right now. Light, the fastest thing in the universe, travels at around 300,000 kilometers per second. It takes light about 8 minutes to reach us from the Sun. So far, so manageable. Now let's go further. The outermost planet in our solar system, Neptune, orbits the Sun at a distance of around 4.5 billion kilometers. Light takes about 4 hours to get there. Voyager 1, the most distant human-made object ever launched, has been traveling for nearly 50 years. As of 2026, it's around 24 billion kilometers from Earth. And it is still, technically, in the neighborhood of our Sun. The Sun's gravitational influence extends far beyond even that. Our solar system, in its entirety, is enormous. And it is a completely insignificant speck within our galaxy. The Milky Way is our home galaxy, a spiral of gas, dust, and somewhere between 100 and 400 billion stars arranged in a disk roughly 100,000 light-years across. 1 light-year is the distance light travels in a year, about 9.5 trillion kilometers. The Milky Way is 100,000 of those. Our solar system sits about 26,000 light-years from the galactic center, a bit over halfway out toward the edge of one of the spiral arms. The Sun takes approximately 225 to 250 million years to complete one full orbit of the galaxy. The last time we were in this part of the sky, dinosaurs were just appearing on Earth. Now, if our entire solar system, the Sun, all 8 planets, the asteroid belt, the Kuiper belt, everything, were shrunk to the size of a full stop on a page, the Milky Way, at the same scale, would be roughly the size of Europe. That is our galaxy. And it is one of perhaps 2 trillion in the observable universe. Here's where we need to slow down and be precise, because there are 2 different things people often confuse when they say the universe. The first is the observable universe. This is the sphere of space from which light has had enough time to reach us since the Big Bang, 13.8 billion years ago. It has a diameter of about 93 billion light-years. Wait, if the universe is 13.8 billion years old, why can we see 93 billion light-years in every direction? Shouldn't the limit be 13.8 billion? This is one of the most common points of confusion in all of cosmology, and the answer is genuinely mind-bending. Space itself is expanding. The universe isn't just full of galaxies moving apart from each other through space. The space between them is stretching. A galaxy whose light took 13.8 billion years to reach us isn't 13.8 billion light-years away today. During the time that light was traveling, the universe was expanding. That same galaxy is now about 46 billion light-years away from us. The edge of the observable universe, in every direction, sits at roughly 46 billion light-years, giving a total diameter of around 93 billion light-years. And this expansion isn't slowing down, it's accelerating. The further away something is, the faster it recedes from us. Beyond a certain distance, roughly 13.8 billion light-years from Earth, galaxies are already moving away faster than the speed of light, not because they're breaking any rules of physics, but because it's the space between us and them that's stretching. Light from those galaxies that we can still see today left long ago when they were much closer. Any light they emit now will never reach us. The observable universe has an edge. Not because space ends there, but because that's as far as we can see. And this brings us to the second thing, the actual universe, the total universe. The honest answer is, we don't know how big it is. We don't even know if it's finite. Current measurements suggest the universe is geometrically flat, meaning space doesn't curve back on itself the way the surface of a sphere does. If it's truly flat and infinite, then there is no edge. The universe simply continues in every direction, forever. If that's the case, everything that can exist does exist somewhere. Every configuration of matter, every possible version of events, an infinite number of stars, galaxies, and perhaps an infinite number of worlds not entirely unlike our own. We have no way to verify this. It may never be verifiable. The regions beyond the observable universe are, by definition, causally disconnected from us. No signal, no light, no information of any kind can reach us from beyond that horizon. We are, in a very real sense, sealed inside a cosmic bubble, not by walls, but by the finite speed of light and the accelerating expansion of space. But let's come back inside that bubble for a moment. Because even within what we can observe, the structure of the universe is almost incomprehensibly grand. Zoom out far enough, and galaxies don't appear randomly scattered. They arrange themselves into something called the cosmic web, a vast network of filaments, sheets, and voids. Filaments are enormous thread-like structures, typically stretching between 150 and 300 million light-years in length, where galaxies cluster along strands of dark matter like beads on a cosmic wire. Where multiple filaments intersect, galaxy clusters form, the densest, most massive structures in the universe. Between the filaments are voids, regions of space that are almost completely empty of galaxies, typically 100 to 500 million light-years across. Voids make up roughly 80% of the universe's volume. And then there are structures even larger than filaments. The Hercules Corona Borealis Great Wall, discovered in 2013, is the largest known structure in the observable universe. It's a concentration of galaxy clusters and filaments spanning somewhere between 6 and 10 billion light-years in length. Some recent analysis suggests it may be even larger than that, up to 15 billion light-years across. And here's the thing. A structure that large shouldn't exist according to our best current models of how the universe evolved. It challenges the assumption that matter is distributed evenly at the largest scales. Cosmologists are still working out what it means. The universe, even within the part we can see, contains mysteries that our best theories don't fully explain. Let me try one final comparison to make this real. Imagine the observable universe, all 93 billion light-years of it, shrunk down to the size of Earth. At that scale, the Milky Way, our entire galaxy, would be smaller than a single atom. And the Milky Way contains hundreds of billions of stars. Every star you can see in the night sky with the naked eye is in our own galaxy. The furthest thing a human eye can see unaided, the Andromeda Galaxy, is about 2.5 million light-years away. At the scale of our shrunken observable universe, it would be a fraction of a millimeter from your fingertip. And the observable universe may itself be only a tiny fraction of what actually exists. This is the scale we live in. This is where we are. A small planet orbiting an ordinary star in one of hundreds of billions of galaxies in a universe so large that our greatest telescopes have only ever seen a bubble of it. And that bubble may itself be vanishingly small compared to the whole. I find something oddly comforting in all of this. Not because it makes us seem important. It absolutely doesn't. But because it means there is so much more to discover than we have yet imagined. Every great telescope we've built has revealed that the universe is larger and more complex and more strange than the one before it showed us. And if the past century of cosmology has taught us anything, it's that the universe is under no obligation to be the size we expect it to be. But no matter how tiny that might make you feel, remember that we're all here. In a universe of chaos, randomness, and unknowing size, humanity is here to find out what's out there. Thanks for watching Voyager's Window. If you enjoyed the video, please like and subscribe for more. Thank you and have a wonderful day.